Hello everyone and welcome to our project presentation for mechanism Sessional at here at IIT Kharagpur. I am Swayam Chavan. Today, along with my teammates Rudra, Dhruv and Tanmay, we are excited to present our design for retractable railway ladder system. So, we have traveled by train and we have all noticed a very common problem. Railway coaches often have significant height mismatch with the platforms. This makes boarding difficult and sometimes unsafe. The existing fixed footboards aren't just adaptable enough. They offer limited support and don't account for varying platform heights. The problem statement was clear. We needed to design a mechanism that is compact, reliable, and easily deployable. It has to provide a safe, ergonomic access, but still fit within the very strict space constraints under the railway coach. To solve this, we set a few key objectives. Firstly, the rudder had to be retractable. It needed a mechanism that provided smooth extension and retraction. And critically, it needs a stable locking system to ensure safety when people are actually standing on it. We also wanted to validate everything through a CAD model and motion simulation. So to do this, we started exploring different mechanisms where where we came across sliding rails and folding plates, but they had issues. A video for sliding rail I'll show a video. This video is a mixture of scissor linkage and sliding rail mechanism. But the one which caught our eye was sliding linkage mechanism. This was actually This mechanism was a perfect choice for three reasons. It was very compactly when stored, it offers strong symmetric load distribution, and it provides a natural extension motion that works very well when deploying steps. Now, for the design calculation and ergonomics part, I'll invite my teammate Dhruv.
Hello everyone, myself Dhruv. Starting with the selection of stair dimension, to ensure comfort, we applied bundle tool which states that 2 times the riser height plus thread length should be close to 620 mm. Using the simple ergonomic principle, we selected link length to be 20 cm. Assuming the extended position of the link at 300 degrees, riser height becomes 17.321 cm, and from this we got thread length to be 28 cm. Also, from the trigonometric consideration, we got the thread length to be around 28 cm, from which we got x equals to 18 cm and the final stair length to be 36 cm. From here, Tanmay would explain the Python code for the 4R mechanism.
Thanks, Dhruv. Once the dimensions were set, we moved to the synthesis phase. We didn't just guess the linkage movement, we used a 4R linkage mechanism to guide the scissor lift. We wrote a Python script to calculate the exact link lengths required for the input and output angles. Let me show it to you. Okay, so this notebook numerically synthesizes a 4-bar linkage given the ground D and the output link C and a desired input angle range theta, output angle range phi. It searches for the input crank length A and coupler length B that makes the mechanism follow that mapping as closely as possible. And this is done using NumPy and Matplotlib, as you can see in this cell. Now, when we move further, for here, for each input angle theta, the code solves the vector loop equation. This is the equation that we are using here, and the unknowns here are the output angle phi and the coupler angle gamma. This is done using this scipy.optimize basically. And as we move ahead throughout the code, we can see that this function, the synthesis underscore error, evaluates a candidate pair a comma b by sampling the input range, solving for phi at each sample, and summing squared angular errors between the achieved phi and the desired phi. Now, as we can move forward, we can see this is the cell where we can get our output and also our plot. Now we will run this and let's see what output we'll get. Okay, as you can see, we have got the best A and the best B. These are the values, and basically this notebook prints the best A and B, the objective value and the plot desired versus achieved of phi of theta for the visual verification. Now this is the visual that we have achieved. As you can see, all the points are exactly mapping on our desired output.
Myself Dhruv. So as we found out the approximate crank length to be 18 cm and the coupler length to be 20 cm, we will now verify the 4R linkage mechanism in GeoGebra. So the crank, so 180 degree will be our initial position for the closed configuration. So starting with the closed configuration, it will move till the 300 degrees. So at the 300 degrees, we will reach the open configuration for the stair mechanism. So continuing with it, for the scissor mechanism, combined with the 4R linkage mechanism, we are using motion gen. So in the motion gen, this white colored link is the ground, this yellow colored link is the crank, this green color link is the coupler, and the purple color link is the follower in the 4R mechanism. And for the scissor mechanism, this purple are the 40 length risers, this is the 20 length riser. For the thread length, this is whole 36 centimeter length, and this is 136 centimeter length. So starting with the motion analysis of it, so starting with the close configuration of the stair, when the train reaches the platform, the stair starts moving from the close configuration to the open configuration. So after the train is ready to leave the platform, it will close from the open configuration to the closed configuration again.
Hello everyone, I am Rudhir Narayan Pradhan and I am here to present to you guys the modeling and motion simulation of our railway ladder system using SolidWorks. As you can see here, we have a ladder mechanism with 3 stairs connected using scissor linkage mechanisms. The scissor linkage mechanism ensure that the 3 stairs remain parallel to each other whenever they move. This particular setup here, this is a 4R linkage and this helps the ladder mechanism to move from the stored position to extended position. This particular link that is marked with blue, it's connected with the actuator and it's basically rotating from 0 degrees up until 120 degrees when the ladder is extended. The dimensions are as follows. As you can see, these are the dimensions. Let's move on to motion studies. So here motion studies, let's play. So here as you can see, this particular link is driving everything. These are the trace of the paths of each different links. We also have the plots of linear velocities. Let's show you. This is the plots of linear velocities of this particular point, and this is the linear acceleration of that specific point as well. The motor is rotating at an frequency of 0.5 hertz. That's why we are seeing repetitions after every 2 seconds. Let's move on to our additional idea that we have implemented. So this particular thing that you're seeing here, it's a linear actuator that is connected with the top surface of the top stair of the ladder system. So what it does is, whenever some uh, wheelchair or other goods they want to come up to the uh, uh, railway coach, this particular link will extend the entire ladder system so that the distance between the stairs is very less. After that, this actuator will move down the top of the ladder. It's fixed. Let's make it float. So this particular actuator will move down the top of the ladder so that the entire stairs, they look like kind of a ramp now. So it's very easier for things to move up and down through this thing. Once everything is done, the actuator will move up and the motor will be keeping everything down. After that, we will be keeping a solenoid valve here that will prevent the movement of this particular input link when the railway, then when everything is traveling, so that whenever the motor is powered off, the stairs doesn't accidentally go to the extended position. Thank you.
Thanks, Rudra. Now I, Swayam, will conclude the remaining of the project. Some improvement ideas we thought about were servo motor for precision control, solenoid locking system mechanism, ramp extension for wheelchair access. Some challenges we faced were maintaining the step horizontally, integrating a locking method, avoiding collisions during motion, and choosing correct link dimensions with synthesis. Concluding the project demonstrates a well integrated retractable railway ladder using a scissor linkage mechanism. Link dimension and motion limits maintain the steps horizontally. Actuator load remain controlled and predictable during operations. RAM mode and extension can improve accessibility. Servo controlled actuation can enable full automation, and our project is suitable for future fully automated boarding systems. Thank you. Thank you, sir, for giving us such an opportunity.